So we're going to learn a new representation called energy pie charts, which we've kind of seen in the simulation already. All right, and in the reading above and from the discussion above, we know now that we're going to have 4 different types of energy that we're going to be talking about, ways that energy is stored. Okay, gravitational potential energy, kinetic energy, elastic potential energy, and dissipated energy. So these are the 4 main ones that we're going to use, all right? So we want to ask ourselves the question each time to see what energy storage modes are present in that part of the scenario based on that state diagram. So here would be like my state diagram, okay? Is the skater above the ground? Yes, okay. So that means he's going to have EG, which we see by potential on this graph. Okay, is the skater moving? No, because the speedometer reads 0 and there's no kinetic. Are any springs stretched or compressed? No, there aren't even any in this whole simulation, so just leave that out. All right, and then dissipated, is there any friction happening? You know, yes, there's going to, but nothing has happened yet. So never, ever, ever in the first pie will there be dissipated energy because nothing's happened yet. All right, so I can see here this entire pie is going to be EG, right, which I can also see here in the simulation. Okay, so I'm going to say in the box, all EG, skater is above ground. Okay, no EK, right, skater is not moving. Okay, no springs at all, so I'm just going to leave that out. Okay, and then no ED because nothing has happened yet. Right, it has to have some time for that rubbing to occur between the board and the ramp before it can transfer anything into the thermal category. All right. Okay, so another one down. So let's take a look again. So now we have a new state diagram. All right. Is the skater above the ground? No. Okay, so I have no EG. Is the skater moving? Yes. The speedometer actually reads pretty high, which means I'm going to have a high amount of EK. All right. And the simulation doesn't show it, but this must have had friction. But he's probably just gone down this hill once. So there's just a tiny little bit of energy that's been transferred into this thermal category, all right? So later we'll learn how to quantitatively calculate this, the exact amounts, but for now we're just looking relatively, okay? So most of the pie is EK because he's very fast, and a little bit of the pie is ED, okay? EK, there's a lot because he's very fast. EG, none because he's on the ground. All right, ED, some friction. Okay, so some energy dissipated. Okay, but not that much yet, right? Because he hasn't had much chance to run against the track. All right. Okay, so third state diagram would look like this. Okay, a little more time has passed. He's probably gone up and down the other side. All right, so let's ask ourselves the question, is he above the ground? Yes. But look, he's not as high as he was before. Okay, technically he's only about maybe a half as high or a third as high, right? So his potential gravitational energy is going to be smaller. Okay, actually let me draw it in the same place that it's on the pie chart so you won't get us so confused. Okay, all right, so I'm going to have some amount of EG because he's above the ground, but he's not that high. All right, is he moving? Yes, but again, slower than before, so he's going to have less kinetic than he had before, okay, compared to this one. Okay, and then thermal, the rest of it has to be thermal or dissipated energy because he has been rubbing that board against the ramp this whole time, which is that keeps going, that's going to generate more and more heat, okay? So EK, he's a little slower, but moving. EG, a little above ground, not as much as before. Okay, in ED, more time has passed, right? More rubbing on that surface has passed. So that's going to generate more in the ED category. All right. Fourth state diagram. This looks like this simulation's been running for a little while now. Okay, because his speed is now very low, and he's very close to the ground. Okay. And this simulation doesn't show it quite very well here, but he's probably moving a little bit of speedometer, okay? So EK, very slow, okay? So he has just a little EK. his EG, very little. He's very close to the ground. Okay, so ED, most of the pie is going to be ED now because all of the rest of that has been sort of taken up. Okay, so here we're going to have a little bit of EG. Maybe on this simulation there's the tiniest little sliver of EK, right, kinetic energy, because he's moving just a touch, and the whole rest of the pie is ED, right? So this has probably been a pretty decent amount of time between these two state diagrams. Okay, eventually, right, the simulation's going to keep running until he has no speed, so none. Okay, no EK, he's not moving. EG, none, he's on the ground. He's not above the ground anymore. So none, none. Okay, the only thing left, the rest of the whole pie has to be dissipated. All right, so a lot of situations, especially when we're talking about the friction, eventually the last pi will eventually be ED, okay, if you let it go long enough. Now, we might have not done that, right? We might have just compared, you know, maybe we just compared these two states, right? We don't always have to compare all the way to the end. All right, but eventually, when you get to here, it's all dissipated, which means this is all not usable energy anymore, right? This guy is just going to sit here. He's not spontaneously going to end up going up or down the ramp anymore. Basically, this simulation is over. All the energy has been transferred into dissipated.